Alrighty, y'all. So the first three problems are basically graphing. So I'm going to go into MATLAB and we'll use the MATLAB to do these first three problems, okay? And it's basic graphing. So let me go to MATLAB. All right, so they want to graph the equation and then choose the correct graph. And y'all, it's not bad. We've got a TI-84 calculator, so you can go right into that calculator and graph this. But we do know the basic shapes of the exponential graphs. And we also know the basic shapes of the fraction exponential graphs. Remember, the fraction ones always went downhill left to right. And the exponentials of the numbers always went uphill left to right. Now, they don't cross over the x-axis, okay? So watch when we graph this here on our calculator. So go to y equals, and I had 1/3, those parentheses, and then my exponent is the variable x. Now remember, you can always use the alpha y equals, the green button y equals, and make it look like a fraction if you want to, okay? So I'm just going to hit graph. And y'all, there you go. The fractions always come down, cross over at 0, 1, and then they try to get close to that x-axis right there. So y'all on that, and it looks like C for us, okay? Comes down from the left and does not cross over. B, yeah, B looks like it comes down below the x-axis, so be careful. All right, so now this one, we got to tell what move it is and then graph it. So let me pull my chat up and I'll let y'all sort of answer some of these. So we know what the base is. The base is 2. But what I want to know is, you got an x plus 2 up there. What's that plus 2 doing to my graph? Would y'all say move it up 2, down 2, left 2, or right 2? Alrighty, y'all. So remember, if you're attacking the x, when you add to the exponent, it's going to actually move me left 2 units. So I'll come down here to D, because that's the one that says 2 units to the left. And my base is the 2 that's being raised to the exponent. So you start with the graph of 2 to the x, and then you shift it 2 units to the left. So it makes you check that, or it'll say next. Oh, hold on, we got to finish the question, my bad. So now we got to actually graph it. So the exponential tool, second tool on the second row, click anywhere. It's going to start it in the same place. We did a horizontal shift left 2 units, so we're going to bring that to -2. And y'all down here where the base is, you got to switch that base to the base of your problem, okay? If you don't switch that base, it will mark those wrong. So then you can save that and go to next. All right, so one more graph and then we'll work stuff by hand. So we know we're going to start with the graph of 2 to the x, because 2 is the base. So we got to figure out what's happening with that +3 there and that -1. So y'all, I'll put in my 2 because that's our base here. So first question, are you going to shift it right, down, left, or up 3 units? And y'all, that 3 is up there with that exponent. On that, and we're going to come down and say left, because we just said If we add to the exponent, it's going to move us left. And then the -1 at the end. Remember, anytime the number's at the end, positives up, negatives down. So that one we would move down 1 unit. And of course, we got to graph this one. So let me click to enlarge my graph. All right, so exponential tool, click anywhere. We did what? Horizontal, we went left 3 units. Vertical, we went down 1 unit. And then we got to change that base from an E to a 2. I also got both my moves. I'm going to hit save and next. All right, so these I'm going to do by hand. I got these already printed here. So y'all just remember the first 3 we're just graphing, okay? That goes back to 7-1 and 7-2. I mean, well, wrong section, 9-2 and 9-3, okay? All right, so let's pick up at number 4 with the interest problem. So they're saying $72,000 is invested at 5.5% interest, compounded quarterly. So y'all, this is the one where we got to come up with the formula that we would use. And then once we get the formula, put in our different amounts for the years they're asking, okay? So for A, we got to find the function. For which, for the amount to which the investment grows after T years. So this is where you want to find our formula. Now we know the basic formula was the amount at any time T equals your principal times 1 plus interest rate divided by the number of compounds raised to the number of compounds times T. So when they say for a function for which it grows after T years, they need everything filled in here other than the T. That way we can put in different amounts for T and get what we need to find, okay? So we're going to come down, A at T equals P. That's our principal or our starting amount. And then we got 1 plus. Now, 5.5% interest, that is 5.5%. So if you turn a half into a decimal, you'll get 5.5, okay? So now to turn that into a decimal from a percent, remember I'm going to move the decimal left twice. So I'm going to have to add a 0. So that's going to be 0.055 all over. N was the number of compounds. So they said quarterly. So remember, if you divide stuff into quarters, you're dividing it into 4. And then N times T would be 4 times T. Now, this is the one Math Lab was picky about. So bring down to 72,000. And then what we got to do is simplify the part inside the parentheses, okay? So let me just go see what I get on the calculator when I punch that in. I'm gonna go to my home screen. So 1 plus 0.055 divided by 4. So you got to get that to be a 1 point whatever that you get on that, okay? So I got 1.01375. All right, y'all. So that's what the inside of the parentheses equaled. So you got to get that part simplified and then bring down your 4 times t. This is what MathLab wants for part A. Now part B, find the amount after t equals 0, 4, 6, and 10 years. All right, so we got our formula now. So now using this formula, we can find the amount when t is 0, 4, 6, and 10. Now this one, they want me to round to the nearest dollar. Okay, so no decimal points. So I'm going to put my 4 times down here. 0, 4, 6, and 10. Now you can do these one by one by putting a 0 in for that t. But I'm going to go put this in y equals, and then I can go to my table and get all these amounts really quick. Because these will be all my x's, and then my amounts will be all the y values, okay? So let me go graph this. So y equals and clear. All right, y'all, so I'm going to put in my 72,000 parentheses 1.01375 close parentheses, and then the exponent arrow up will be 4x. Just got to remember on the calculator, you got to use x's instead of t's, okay? All right, so let's go to the table. So second graph to go to my table. All right, so 0 is the first one I got, and it says 72,000. And then t equals 4, I'm going to come down to 4. And at 4, I'm at 89,583. So if you notice, it's rounding me off to the nearest dollar. Now, if they wanted me to round off to the nearest cents, remember, if I go to the y equals row over here and highlight the blue part, it gives me the decimals down below. So the calculator is actually rounding it off to the nearest place on these y values. All right, so 4 was 89,583, y'all. So next was 6. We got 99,925. And then down here at 10, I can scroll down and we're at 124,327. So that's one thing I love about graphing calculators is when you got equations, you can come plug them in and go to the table and get all these values really quick. So remember, these were my x's, and then these values were my y values, okay? All right, next is number 5. So number 5 was using this formula again. And this is where the little girl had the birthday, okay? So on Melissa's 6th birthday, she gets a $6,000 CD that earns 7% interest compounded quarterly. If the CD matures on her 13th birthday, how much money will be available? So number 4 here, we learned about getting the formula and how we could plug in to get each of the values. This is an actual application problem using that formula. So we know it's going to be A of t still, and then A of t equals the P, which is my starting amount. Well, we know the starting amount was 6,000. And then we got parentheses 1 plus, well, I got 7%. If you move that decimal left twice, we're going to add a 0 and make that a 0.07. So we put that on top. N is on bottom, the number of compounds. Oh, this one's what? Compounded quarterly again. So we know quarterly is 4. And then close parentheses, and it'll be 4, because that's my N, times T. So T is the number of years. So y'all, for that, T will equal, it matured on the 13th birthday, minus it started on her 6th birthday. So time looks like it matured for over 7 years. So that'll be 4 times 7 as your exponent up there now. Now, y'all, this one says round to the nearest cents. Okay, so we're rounding it to the nearest cents. So that means 2 decimal places. All right, y'all, so I'm just going to go plug it in. So let me get on my home screen. All right, so we started with $6,000. Parentheses 1 plus 0.07 divided by 4, close parentheses, and then my exponent was what we have, 4 times 7. Hey, y'all, remember, nearest cents, we're looking for 2 decimal places. So it looks like we're getting $9,752. And what we got? 47. Oh, but the 7 has the 7 behind it. So we'll make that a 0.48. Hey, y'all, that's the trick on those 2 problems, is just use the formula, plug in what you know, and then get them answers, okay? All right, now, starting at number 6, we started having to find logarithms, like on a calculator and stuff. So number 6 says find the logarithm. All right, y'all, we got a log base 10 of 1. So basically, what is the log of 1 equal? What exponent would you raise that 10 to give me a result of a 1? I don't know. Is my chat working today? All right, well, y'all can actually punch this on front of the calculator. Remember, you could use the log. Well, think about this. 10 to the first power would equal 10 here. So if this was a 10 here for my result, then 1 would actually be the answer for that. Y'all, how about this if I say it like this? It don't matter what this base is. This can be any base. If that result equals 1, there's only one exponent in the world that can turn any number into a 1. So y'all remember here's what you got to think about this. This is like a base 10 to some exponent here is going to equal that 1. All right, y'all, let me go get y'all real quick on this calculator. Oh, now you got it. Now you got it. You definitely got it now. But y'all look at this. Log of 1 equals 0. Y'all remember, I don't care what this base is. If that results a 1, that exponent has to be 0. Okay? How about this one? Log base 4 of 4 squared. So a log base 4 of 4 squared. I got a log base 4 with a result of 4 raised to the second power. Remember, every time we had this situation, if this base matched the base raised to an exponent, that answer will always be that exponent. Good job. You know, remember, you can punch this in using the log base feature. Let's go do that. So math, arrow down to log base, hit enter. My base was 4. My result was 4 raised to the second power. Now that all that's in, I hit enter, I get that too. So y'all remember, you can do all these logs on that calculator. Find a log. Log base 9 of 3. So what kind of exponent do I get when the result is smaller than the base? Well, y'all, you can punch that in. I had a log, so I'm going to go to math and go down to log base. Hit enter. My base was a 9. My result was a 3. I now hit enter. Now I get 0.5, but remember to turn that back into a fraction. I can hit math and enter twice. So I get a 1/2. So when the result is smaller than the base of the log, we always got fractional exponents for our answers, okay? All right, y'all look at this one. A log base 20 of 1. So look like mine's getting a little reciprocity type thing going on, right? Oh, well, y'all should know that in really quick because that results of 1. So that means this one has to equal 0. Because right here, anything with a result of 1 equals 0. Don't matter if that base is a 20. Results of 1, exponent has to be a 0. Oh, y'all, number 10, they started wanting us to convert to a logarithmic equation. I got 10 to the fifth equals 100,000. All right, so this is exponential. They want me to turn it to logarithmic. So you have to write your log. The base of the log is the same as the base of the exponential. So that's going to be a log base 10. The result is the result of the exponential, which is the 100,000. And this equals the exponent, or the exponent was the 5. Okay, so remember, these are just where we're going through the conversions from logs to exponential. And y'all 11, same thing, convert to the logarithmic equation. So it looks like they got us doing a couple converting to logarithmics, and then they'll do a couple where we're going to convert them to exponential. Now this one has e to the negative 4 equals t. Alrighty, so we're turning it into a log. The base of the log is the base of the exponential, which is an e. The result of the log is the result of the exponential, which is t. And that equals our exponent, which was negative 4. Now this one will take that answer. It'll take this answer, or realize the log base e, I can write that as another way. Log base e, we can write as ln of t equals negative 4. Okay, so math that takes it either way. But remember, ln really is a log base e, okay? And then the log, any log that don't have a base is really a log base 10. Any other log, we have to write the base down there and use the log base feature of the calculator. All right, y'all, number 12. Okay, like I said, these two were converting to exponential. All right, so these will start with the log. Log base 2 of 4 equals 2. So you're going the opposite direction. So the base is equal to the base of the log, which is a 2. The exponent is what the log equals, because remember, a log equals the exponent. So 2 is your exponent. And then that equals the result. Okay, the result is the 4. Okay, so you just got to remember this is the base, result, exponent. Okay. All right, y'all, 13, same thing, convert to exponential. But remember, they got you doing this. They're having you do this because remember when I started solving equations, if I couldn't do all that log base stuff on each side, I had to rewrite them as exponential, okay? And this is all the reason why we had to learn these. All right, y'all, log base A of a capital T equals a negative little z. So capital letters got to be capitalized, lowercase letters, vice versa, okay? All right, y'all, the base is the A. The exponent is the negative z, and that's going to equal the result, which is the capital T. All right, 14 says use a calculator. To find the natural log. So a natural log, they're talking about an ln. So they got ln 346.1. Now these we're going to round 4 decimal places, okay? So 14, they want you to use a calculator, but they want you to use the buttons on the front, okay? So let's go use the LN button that is on the front of this calculator. So right to the left of the 4 is our LN. So we click that, and then we got 346.1. All right, I'm going to hit enter. Remember, I'm rounding 4 decimal places. So this will be 5.846. Okay, the 7's in the 4th spot. Got a 2 after it, so I'm going to keep that a 7. So 5.8467. So 14, they want you to use the LN on front of the calculator. Now look at 15. 15 says find the logarithm using change of base. And they want me to find log base 7 of 14. Well, when you had any other base other than the log base 10 and the log base E, the LN stuff, they want you to use change of base. What that means is when you go to math on the calculator, go down until you get to log base. Okay? So you'll punch on log base, put your 2 numbers in, and then find it. Okay? So we're using change of base since it's not one of the 2 main log buttons on the front of the calculator. All right, so remember, math, scroll down to log base, enter. So we had a 7, and our result was a 14. So this will pretty much approximate the exponent that you would have to raise that 7 to get a 14. And that would be 1.356. And let's see, the 2 has a 0 behind it, so I'm going to keep that a 2. So 1.3562. So y'all, that's the big thing on those logarithms is rounding them out those 4 decimal places, okay? You know, it's not too bad a test because you got a lot where you could use the calculator. Now we're going to start getting into the properties. So those exponent properties, I had the product rule, quotient rule, power rule, okay? So this one says express as a sum of logs. All right, y'all. Log base 19 of 19 times 361. Now listen, don't oversimplify this one because Math Lab will count you wrong. They just want me to express it as a sum of logs. So I distribute the log to both of the factors in here and write it as a sum. So I'm going to have a log 19 of 19 plus my log 19 of 361. That's all they wanted me to do to this. Okay, they don't want me to figure out that this equals 1 and this probably equals 2 and 1 plus 2 is 3. They don't want me to go that far. They want me to stop right here on this problem, okay? All right, 17. Express as a product. All right, y'all, they got a log base 2 of p to the third. Well, this is a base 2 with a result of t to the third. So when they say express as a product, that means take this exponent down to the front. So you want to bring the exponent down to the front, which gives you 3, and then multiply times the log base 2 of t. That's one of our main moves that we've been doing in these equations. That's how we can solve when the variables are up here as an exponent. We do the log stuff to them because we want to bring them exponents down so that we can solve for those later. So you're taking it from an exponential type situation and writing it as a product here, okay? All right, this says rewrite as sums or differences. Now this one, you got to simplify all the way through if you got things that you can do to it, okay? So they're giving me for 18 an ln parentheses x to the 7th, y to the 5th, and z. Okay, so y'all had those properties of logarithms. Stuff is being multiplied. When it's being multiplied, we wrote it as a sum. The only way you'll get differences is if it was being divided, remember? So on this one, it says or. Well, all I got is products, so it's going to be sums, okay? So I get an ln x to the 7th plus ln y to the 5th plus ln z. So I just distributed my ln through there. And then my last step looks like that. Got it? You brought them 7s down. Good job. And then you brought that 5 down. So remember, exponents got to come down. Good job. Okay, y'all, and then that would be our final answer, okay? So all these properties we're hitting now were really to get us good at solving those equations, okay? Okay, so I think I'm gonna bring 19 down here. Not no room up here for 19 because y'all look at 19. It wants me to express log base b of a p squared q7 over m3 b7. So express this as in terms of sums and differences. Now notice, Up here they said or, which means either or. Here they're saying and. So that means we will have some of these being sums and some of these being differences. So what you got to do when you distribute that log B, if the factors were on top, they're added. And remember, if the factors were on bottom, using that quotient rule, the factors from the bottom were subtracted. So you're going to distribute log B to all four. So the P squared's on top, it's positive. And then the log B of Q7, because the Q7's on top. Now we start subtracting. So distribute log B to the bottom. And M3 is on bottom, so it gets subtracted. And then, same thing, distribute log B to B7. So the two are positive on top, two negative from the bottom. Now, three of these, you're bringing the exponents down. But here, log base B of B to the 7th, what you got there looks like, good job, y'all, it would be just a 7. Because the base and the result raised to that same base matches, then it equals that 7, good job. So you get 2 log B of P plus 7 log B of Q. All right, then you got me going. What you got next? Minus 3 log B of M. And then minus, good job, 7 at the end. So you got to simplify this to a 7. You got to bring the exponents down for them to give you the right answer on that one, okay? And y'all, that's really the tricks on this thing is keeping up with signs and then those exponents coming down and then these kind of properties, okay? So keeping up with them is really the trick on this test. All right, 20, it just says simplify. They're using ln. ln of x squared plus 11x plus 24 minus a ln of a x plus 8. So y'all, the trick would be to write this as a single logarithm first. So this stuff is being subtracted. So we know it's going to look like a quotient. So bring out your ln, and you're going to have a quotient there. The top is the positive factor, x squared plus 11x plus 24. And then the only factor on bottom will be what's being subtracted, and that's the x plus 8. So your first trick was to write it as a single logarithm. But y'all look at this one. Anytime you got quadratic equations and then other factors, you want to see if this stuff will simplify. Now, we can't really do nothing to the bottom at the moment. But the top, we're going to try to see if we can factor the top of this. And let's see. And you got to remember, okay, I see y'all already popping some stuff up there. 8 and 3, yeah, that's factors of 24. Good job. That add to get 11, and y'all are good. They're both positive. And y'all look at that. Since y'all factored that, this x plus 8 factors cancels with that x plus 8. So we're only left with, now here's the thing, although the fraction goes away, since we got two parts, they got to be written in parentheses for this answer, okay? Now, there is one, I think, later where we didn't have to do that, because if you just write it like this, MATLAB will think you're only doing the ln of the x, and then you're just adding 3 to it. So that's why on this one, you definitely want to put them in parentheses, because it's taking the ln of this whole thing, okay? Oh, y'all was nice on that one. I'll actually tell you what's nice on that. And look, they give you the answer for that one. So that was one of ours where we did multiple choices on some of these, okay? And here's the one before. That looks like the one Matt had for us and Jackson with that 7 and stuff. So yeah, you'll see the ones that on some of these, so you don't have to worry about parentheses, I guess, on that since they're giving us a multiple choice. All righty, y'all. Let's see. This would be what, 21? Solve for x. All right, y'all. So it looks like this will be the last one before break. So I got 5 to the 5x equals 625. So exponential, my first step would be to try to see if I can rewrite both sides of this using the same base. So my question is, can we rewrite 625 with a base of a 5? So basically, can I start multiplying fives and equal 625 by just multiplying a bunch of fives? Well, 5 times 5 is 25. 25 times 5 is 125. 125 times 5 is 625. So Nat, good job. You got 5 to the 4th, because y'all look here. Here's my base 5, and I had 1, 2, 3, 4 of them. So that makes that exponent a 4. Good job. So y'all, that gives me 5 to the 5x equals 5 to the 4th. So I'm going to rewrite it, doing what we just said. Now bases match, so 5x. Whoops, that's a 4 right there, right? All right, y'all. So I was talking x's and writing, or talking 4s, writing x's, but remember, 5 to the 5x equals 5 to the 4th. That's what I did that for. Now bases match, so 5x equals 4. All right, y'all, one more move, we're done. We're going to divide both sides by 5. Those cancel, giving me 1. And then can't do nothing with that. 4/5. So if I put the 4/5 here, the 5's cancel. 5 to the 4th is 625. And then we would be done. Good job, Jackson. 4/5. Yep, that's what I got right there too. So good job. All right, y'all. So we'll come back after break and finish this thing out. So it's 10 till, so we'll take our break until 11 o'clock. All right, y'all, looks like 11 o'clock. So I want to get us recording again. All right, so it looks like we're on number 22. So 25 altogether. So we got 3 more to go. But they're all equations, okay? So they say solve 3 to the x equals 5. So an exponential equation. So 21, I was able to rewrite both sides using the same base. Well, on this one, I cannot rewrite each side using the same base. So remember, when we couldn't rewrite each side using the same base, we had to take logs of both sides. So a log of 3 to the x equals a log of 5. And then once again, like we said earlier, we have to take logs so that now we can bring that exponent down to solve for it. So I get a x times log 3 equals log 5. And then y'all, what was my last step? Divide both sides by log 3, so that becomes a 1x. And then those cancel, you're left with a 1x. And then remember, we're approximating this because this is going to give me a decimal answer. But y'all remember, the trick is close those parentheses when we punch in our logs, okay? So let's go punch that in. So I had a log of 5. So log of 5, close parentheses, divided by a log of 3, close parentheses. And remember, 4 decimal places. So that's going to be 1.46. And what I got? Oh, 49. But y'all, the 9 has a 7 after it. So the 9 is turning into a 0, which means the 4 is turning into a 5. So that'll be 1.4650 on that one, okay? All right, and then that was what, 4 decimal places? All right, y'all, looks like the last 3 are all log equations, okay? So 2023 says solve for x. They got a log base 4 of 4x minus 5 equals 4. All right, so you got a log equation. There's only one log on the left side, so I don't have to combine any logs. I don't have logs on both sides, so I can't do the log base property. So since I only got one log on the left side equal to a number, I'm going to rewrite this one as exponential. So that's why y'all had to do them problems, I think, around 14 and 15. So the base is 4. The exponent is 4. And that's going to equal that result, 4x minus 5. All right, so let's figure out 4 to the 4th power is 256 equal to my 4x minus 5. And then y'all, at that point, it's just a matter of um, adding 5 and then dividing. So get the x by itself by adding 5 to both sides. So y'all, this is what 261 equal to my 4x. And then divide everybody by 4. Oh, y'all, here you go. That cancels, giving me my x. Oh, y'all, I don't think 261 over 4 is going to reduce. So that'd be my final answer. So let's see, if I put 261 over 4 here, the 4's cancel, and I get 261 minus 5, which is 256. So the log base 4 of 256 equals 4 would be a true statement, so we can keep that answer, okay? All right, so that one they started out sort of mellow, gave me 1 log equal to a number. 24, look what they're doing. Log base 5 of t plus 32 minus log base 5 of t plus 5 equals a log base 5 of a t. So I got logs on both sides, okay? So our first step, since the left side has 2 different logs, we're going to combine logs on the left side. Now remember, they're being subtracted, so when you write it as a single logarithm, it's going to look like a quotient, the positive factor on top, factor being subtracted on the bottom. So bring out that log 5. I'll have my t plus 32 on top over my t plus 5. So that's the left side written as a single log. That's going to equal log base 5 of t. So y'all, what do we notice on this one? We got logs on both sides and they both got the same base. So when the bases of the logs match on both sides, this result equals this result. So the t plus 32 over t plus 5 equals the t on the right side. And y'all, this is where I sort of made it look like another fraction by putting a 1 under the t, and I'm going to cross multiply. So this t plus 32 gets multiplied by 1. So 1 times t is t, plus 1 times 32 is 32. That's going to equal the other side when I take the bottom times the top. So t times t is t squared, plus t times 5 is 5t. So if you notice here, you got a t squared term in here. So that makes this quadratic. So to solve quadratics, we need everything on one side equal to 0. So y'all, your next step would subtract t from both sides and subtract 32 from both sides. So t minus t is 0. 32 minus 32, 0. So the left side is a big 0. So what did we get over here? We brought our t squared down. 5t minus t left us 4t. And then the minus 32. Okay. So, yep, you got it. We're going to factor this. All right, y'all. So let me pull my chat up so y'all can factor me. 4 and -4. So let's see. Oh, that looks good. Hold on, let me see what that chat said. 8 and -4. Good job. All right, so t plus 8, t minus 4, because remember they had to add to get that +4, and they had to multiply to get that -32. All right, y'all, so the rest of this was just coming back in and solving both of these by setting them both equal to 0. So y'all, we get what, a -8. This one we're gonna get a +4. So what are we putting in Math Lab though? And 4 is the only one we can take, right? Because remember that -8, we can't count negative answers when you're dealing with logs. So the only answer is t equals 4 for that one, okay? All right, y'all, that leaves us one more to go. So number 25. And guess what? Solve again. So they gave me a problem where I had a log on one side equal to a number. They gave me a problem where I had logs on all the sides. And now this one, they're giving me two logs on one side equal to a number. So y'all look here, a log base 3 of x plus 4 plus a log base 3 x minus 4, all that equal to 2. So they like keeping you honest with all the different types of logarithm equations, okay? But remember, you got 2 on the left side, so we're going to combine logs. So while they were being subtracted, we wrote that as a quotient. These are being added, so we're going to write it as a product. So bring out that log 3, and then we'll have our x plus 4 times x minus 4. So sums are written as products. All that equal to our 2. And I'm going to go one step further and actually multiply this stuff. Now, conjugate pairs, I got to FOIL this, but since they're conjugate pairs, I get the shortcut. I can do x times x and get x squared. And then 4 times -4, give me -16. All equal to our 2. So now I got log base 3, x squared minus 16 equals 2. So guess what? We're at the point where I got a log on one side equal to a number. We're going to rewrite it as exponential. So the base is the 3, exponent's the 2, and that's going to equal this result of a x squared minus 16. And y'all look at that. First, we know what 3 times 3 is. So 3 squared equals 9. So 9 equals x squared minus 16. So y'all, at this point, you can do two things. You can pull the 9 over here and solve this one by factoring, because you're going to have perfect squares. Or you can add 16 to both sides and take square roots. So usually I would add 16 and do square roots, but let me do it the other way this time. So that's going to give me a 0 equal to x squared minus 25. So notice, this is like this. This was the difference of perfect squares. It would factor into conjugate pairs. This is the difference of perfect squares. It's going to factor into conjugate pairs. X squared is an X and an X. 25 is a 5 and a 5. So guess what? If you'd have pulled the 16 over here and had a 25 equal to X squared, square root of 25 would have gave you these 5s, okay? All right, y'all, so to finish it off, and that's why these ones, like number 24 and 25, the reason you're getting unlike signs is because the answer can't take both of them. And we're only getting one answer technically because we're throwing that other one away, okay? All right, y'all, so look here. Here's that -5. And here is our +5. But if you put that -5 in here for these x's, you're going to get negative numbers, and we cannot take a log of a negative result. So we're going to throw away the negative answer again, and the only answer is going to be x equals 5. Okay, y'all, so this test started out with a little graph and got into the interest problems, a couple of those. Then you had to start evaluating logarithms, and that's basically all calculator work. Oh, then we got into what? Rewriting as logarithmic and rewriting as exponential. Then we got into those properties of the logs, and y'all finally ended up with our solving exponential and solving logarithmic equations, okay? So y'all, that is test 4. Now, copy this down. Let me share my screen. Copy this down. This is what you're going to send me for the bonus. I'm not going to do work on this one because Blackboard's, I'm having issues trying to get my upload links into it. So don't worry about sending me work on this one. But if you want the bonus points, you got to send me this in an email, okay? So let me share my screen. All right, y'all. So on this one, bonus, you're going to send me the answer via my email. And there's 2 parts to get these 5 points, okay? First, I want you to evaluate log of 1. Second, using a calculator, I want you to do log of a -100. And I'll put these in an email later. But y'all get both of these, you'll get my 5 points on test 4. And then I still got to add points for some of y'all for test 3 bonus, okay? So I ain't forgot, I just haven't had time yet. But that'll be the bonus for test 4, okay? And when I send this video later, I'll put these bonuses in it also, okay? All right, y'all. So